Hi guys. Hey, I just wanted to go back and look at some things we were talking about on Friday about power series and how we can use the power series to represent a function for certain x values and interval of convergence and all of that stuff that we were talking about on Friday. Okay? So to start this problem, find a power series that represents 1 over 1 minus 2x on the open interval negative 1 half to 1 half. Okay? What we want to go back and look at is just the regular power series. Okay? 1 over 1 minus x. Now this function can be represented by a power series because your first term is 1, and this just comes from a geometric series, and then your r is this x right here, okay? So this can be represented by the series, infinite series, 1 plus x squared plus x cubed plus x to the fourth plus dot 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 plus x to the n plus dot dot dot, and this is equivalent to sigma n equals 0 to infinity of x to the n power. Now you can always make sure that this works. Put 0 in for n and you get x to the 0, and yeah, it's 1, right? Now this only works when this x, remember for a geometric series, it only works when the absolute value of r is less than 1, right? And in this case, our r is x. So this only works when the absolute value of x is less than 1. This translates into negative 1 less than x less than 1, okay, which is the interval negative 1 to 1. Now, everything else that we're going to do here spins off of this 1, okay? And we just look at it different ways, like what is your r? Okay, so in this case, we have 1 over 1 minus 2x, and we want to show that it converges on the open interval negative 1 half to positive 1 half, okay? So we can use this fact that 1 over 1 minus, but instead of x, we're going to put 2x, and that's equivalent to this. So it's just replacing all of these x's with the 2x in essence. Okay, so this would be 1 plus, and I'm just use parentheses, you wouldn't have to, okay, for this first one. So plus 2x plus 2x squared plus 2x cubed plus 2x to the fourth plus dot 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 plus 2x raised to the n plus dot dot dot. Now we can clean this up a little bit. This would be 1 plus and then 2x. This would be plus 4x squared plus, and this would be 8x cubed plus 16 x to the fourth plus dot 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 plus 2 raised to the n power x to the n power plus dot dot dot. And writing this as in sigma notation, this would be equivalent to sigma n equals 0 to infinity of our nth term here, which would be 2 to the n power x to the n power. Now, these aren't always the same because it has to do with that interval of convergence that we were talking about, okay? So this 2x, which is our r, okay, has to be less than 1. So not 2x, the absolute value of 2x. So absolute value of 2x has to be less than 1. Okay, that translates into negative 1 is less than 2x, which is less than 1. And then dividing each of these by 2, we get negative 1 half, which is less than x, which is less than 1 half, which is the open interval, negative 1 half to 1 half. So this function 1 over 1 minus 2x and the infinite series that's represented by right here and also in sigma notation, these are the same, but a couple things. They are only the same for x's between negative 1 half and 1 half, and the series has to go forever. Okay, for this next one, we want to find the power series that represents 1 over x, okay? Now, how do you come up with this? And we're going to talk about this in a minute, okay? But we want to show that's a power series that represents this on this interval 0 to 2. Okay? So if we start with 1 over x, okay, I need to get it into that form of 1 over 1. Well, it doesn't have to be 1 on the numerator, okay? In this case, it will be because this is 1, but it's going to be 1 over 1 minus something, okay? We need to get it into that form where the denominator is 1 minus, okay? So we still need it to be equivalent to x in the denominator. So what we can do is take the 1 over, and I'm going to take 1 because I need a 1 right there, and I'm going to add x, but then I'm going to take 1 away. Because if you have 1 plus x minus 1, that is still x, right? Okay. All right, now I need it to be 1 minus. So one thing that I can do, okay, is to rewrite this as 1 over 1 minus, and basically what I'm going to do is I'm going to factor a negative out of this. So it's going to be a negative x plus 1, because I can factor 1. So negative x plus 1. Okay. All right. Now, one other thing that we can do. So now this is our r right here. Okay, so we could rewrite this as 1 minus x. I'm going to do something a little bit differently because it's going to help us for the next problem. We can pull a negative even out of this. So this becomes 1 over 1 minus bracket, and then negative 1 times x minus 1. Okay, so now our multiplier is negative 1 times x minus 1. This is, I know you don't quite understand right now, but what this is going to cause is us to have an alternating series. Okay, and we talked about alternating series tests and all of that kind of stuff. Okay, so here we go. This 1 over x is equivalent to 1 over 1 minus, and then negative 1 times x minus 1. Okay, and this is our r, so then this is equivalent to our first term is the numerator here, which is 1, okay, and then plus, okay, and our multiplier, our r, is negative 1 times x minus 1. So this becomes, I'm going to use a bracket here, negative 1 times x minus 1, and then plus negative 1 times x minus 1 squared, plus negative 1 times x minus 1 cubed, plus dot, 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 plus, and then negative 1 times x minus 1 to the nth, and then I should have plus dot, dot, dot at the very end. Okay. And so this 1 over x is represented, I'm going to skip this part right here, it's represented by 1 minus x minus 1. This is going to be negative 1 squared, so that'd be plus x minus 1 squared. You see how we're getting the alternating? And then the next one's going to be negative 1 cubed, so that's going to be minus x minus 1 cubed plus dot, 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 plus, and this is going to become negative 1 to the nth times x minus 1 to the n plus dot, dot, dot. And then we can write this in sigma notation, okay? And so this is equivalent to sigma n equals 0 to infinity, has to go to infinity, negative 1 to the n times x minus 1 to the n power. Okay, now what was our r? Our r was this, negative 1 times the quantity x minus 1. Okay, so this r, okay, the absolute value of r has to be less than 1. Okay, so the absolute value of r has to be less than 1. Okay, so our r is this though, so it's absolute value of negative 1 times x minus 1 has to be less than 1. Okay, that would mean that this has to be between negative 1 and 1. So negative 1 is less than negative 1 times x minus 1, which is less than 1. And there's different ways you could go about doing this. You could divide the left, the middle, and the right by negative 1, and then you change the direction of inequalities. You could also distribute. So there's different ways you could do this. I'm going to distribute it. Okay, so this is negative 1 is less than negative x plus 1, which is less than 1. And what I'm going to do is I'm going to take 1 away from the left, the middle, and the right. So that makes negative 2 is less than negative x is less than 0. And then I'm going to divide by negative 1. So that's going to make this 2. I'm going to change the direction of the inequality. So instead of less than, it's going to be greater than x. And divide this by negative 1. And I'm going to change the direction of this inequality, which is greater than, and this would still be 0. Now, this isn't the normal way of doing it, or normal way of writing it in between. This is really in between. X is between 0 and 2, right? The normal way is 0 is less than x. So we're going to read it right to left instead of left to right. 0 is less than x, which is less than 2. And that is the open interval 0 to 2, which is what we have up here. Now, I realize this might be a little bit differently than I showed you on Friday. I just thought of it a little bit differently to explain to you. Okay, for our next problem, find a power series that represents 1 over 3x. And that 1 over 3x is going to be rewritten as 1 over 3 times 1 over 1 plus this x minus 1. And then we also want to give its interval of convergence. Okay, so I want to talk about how we come up with this. Okay, so first of all, 1 over 3x. Well, 1 over 3x can be rewritten as 1/3 times 1 over x. Okay, and then building off that, okay, so this is going to stay 1/3. I'm going to use a bracket here. And then we have 1 over, okay, so we want to make this become a geometric series. Okay, so we could do that by taking 1 plus x and then take away 1, because that would still be 1 over x. Okay, now this needs to be, I'm starting with a 1 here and not x, because you could do x plus 1 minus 1, but I'm starting with the 1 right here because the geometric series sum always starts with 1 right here. Okay, so it's 1 minus. Okay, so again, how can we get this to be minus? Okay, well, you can factor a negative out again, right? So this becomes equal to 1/3 times 1 over 1 minus, I'm going to factor a negative out of this and this, so it becomes minus, and then negative x plus 1. I need to extend my fraction bar a little bit there. Okay, so this is our r right here. Okay, that's our r. So 1 over 3x is equivalent to 1/3 bracket. Okay, and then 1 over, and then 1 minus, and I'm going to use a bracket here because our x is negative here, so I'm going to factor a negative like I did it earlier. So negative, and then parenthesis x minus 1. And again, there's other ways to look at this. Okay, so our r is negative of x minus 1, or negative 1 times x minus 1. Okay, so this is going to be 1/3 times this, but this can be represented by a geometric series, right? Or a power series. So this is going to be 1/3 and then times, and it's, our first term is going to be this 1, okay? And then we're going to add to that, because we're multiplying this by our r is negative times x minus 1, so negative parenthesis, x minus 1. Then that'd be to the first power. And then plus, bracket, negative of x minus 1 to the second power, plus, bracket, negative x minus 1 to the third power, and then plus dot 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 plus, and then negative times x minus 1. You know what I did? I put the 3 on the wrong spot. Let me get my white out. Yes, I still have white out. Because where should that 3 be? 3 should be outside the bracket here. Okay, and then negative 1 times x minus 1, and then close the bracket, and then raise to the n, and then plus, and then dot, dot, dot. Okay, cleaning this up a little bit, this becomes 1/3, and then sigma, or not sigma, bracket, okay, and we have 1, and then this becomes minus x minus 1, and we have negative 1, this is negative 1 squared, which would be 1, okay, so plus, and then it would be x minus 1 squared, and then minus, because this is a negative 1 cubed, right, so minus x minus 1 cubed plus dot dot dot, okay, and this is going to be plus, and this is going to be negative 1 raised to the n, and then x minus 1 raised to the n, and then plus dot dot dot. Okay, and so this can equal, all right, once again, 1/3 times, and it's going to be sigma, and n equals 0 to infinity, and it would be negative 1 to the n times x minus 1 to the n power. Okay, so one thing you can do, one property, if we had, you could distribute this 1/3 in here, right? And then that 1/3 could get distributed in here. So we can bring constants outside the sigma notation in. So we could, an alternative way of writing this is sigma n equals 0 to infinity. It would be negative 1 to the n times x minus 1 to the n all over 3. And we can write it like that. And now we got to figure out the interval of convergence, okay? So back to this, what's our r? Our r way up here, r is equal to, let me slide this up a little bit. Our r is equal to negative of x minus 1, or negative x plus 1. So absolute value of r, which is absolute value of negative x plus 1, has to be less than 1, which means negative 1 has to be less than negative x plus 1, which has to be less than 1. Subtracting 1, we get negative 2 is less than negative x, which is less than 0. Dividing by negative will change the direction of the inequality, so we're going to have 2 is greater than x and greater than 0, which means 0 is less than x, less than 2. So it's the same interval of convergence as the last problem. It's just we're multiplying by 1/3, okay? It's pretty much the same, okay? So the interval of convergence, and I'll slide that up. I'm sorry you guys couldn't see that. Okay, so the interval of convergence is 0. Okay, for this next one, find a power series that represents 1 over 1 plus x squared on the open interval negative 1 to 1. Okay, so what we need to do is rewrite this. Okay, so it's the idea of the first term of the series over 1 minus. Now, how can I write this as 1 minus? Well, this is how we're going to do it. Okay, so we can rewrite this as 1 over 1 minus, right? And to make it still be plus x squared, we're going to be subtracting a negative x squared. Okay, and I should have put in this. This is the same as 1 over 1 plus x squared. Okay, so now we can see our r is this negative x squared. So this would be equivalent to, okay, I should put it here. Okay, I'm going to erase that, equals right here. Okay, so this would be our first term, which is this numerator, right? 1. And then what I'm going to be multiplying by is this negative x squared, okay? So plus a negative x squared, and then plus a negative x squared squared, and then plus negative x squared cubed, and then plus, I'm going to put my dot 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 here, plus negative x squared raised to the n power plus dot dot dot. Okay, cleaning this up, this would be 1 minus x squared. This would be a negative 1 squared and then x squared squared, so that'd be plus, that'd be a positive 1, and x to the 4th, and then negative 1 cubed, which would give us a negative, so minus, and then x squared cubed would be x to the 6th, and then plus dot dot dot. Now this one would give us, and then plus right here, and then negative 1 to the n, and then x squared to the x squared raised to the n power, which would be x to the 2n power, and then plus dot dot dot. And then this would be written in sigma notation. Sigma n equals 0 to infinity, and then it'd be negative 1 to the n power and x to the 2n power. And what's the interval of convergence? Okay, so let's talk about that, okay? So my r up here, my r is negative x squared. So that means the absolute value of negative x squared has to be less than 1. Okay, we can't get rid of the, well, if you take the absolute value of this, okay, it'd be, this is like negative 1, and one property is, if you have, for absolute values, a property of absolute values is, if you take the absolute value of a product, so like a times b, that's equivalent to the absolute value of a times the absolute value of b. Okay, so this is negative 1, right? And the absolute value of negative 1 would be 1. So this winds up being the absolute value of x squared, okay, is less than 1, right? Okay, but what do we know about x squared? It's gonna be positive or 0, okay? So we really don't need the absolute value here, okay, because it's never going to be negative, okay? So now what we have is x squared is less than 1. Now I can square root both sides, okay, and this becomes the absolute value of x, which would have to be less than 1, which would mean negative 1 is less than x is less than 1, which is the open interval, negative 1 to 1. Okay, from the last problem we just looked at, 1 over 1 plus x squared can be represented by this infinite series, power series, okay? And if we recall that 1 over 1 plus x squared is the derivative of tan inverse. So if we were to integrate this, we would get a power, and we would integrate the power series, okay? If we integrate this, we would get a power series for tan inverse of x. So let's go ahead and do that, okay? So I'm going to slide this up, okay? So what we're going to do is we're going to integrate from 0 to x, from 0 to x of 1 over 1 plus 1, gosh darn it, 1 plus t squared and then dt. Because when we take the antiderivatives, it's going to give us tan inverse, and then we would put this x in, which would give us the tan inverse of x, okay? So this is equal to the integral, also from 0 to x, of the power series that we had above, okay? So it's I'm going to use a parenthesis here, 1 minus, and these are all going to be t's too, so t squared plus t to the 4th minus t to the 6th plus t to the 8th, and then minus t to the 10th. I put a few more terms than we had above, and then plus dot dot dot, and then plus, and then this would be negative 1 to the n, okay, and then x raised to the, or not x, should be t, so let me fix that, t to the 2n power, plus dot dot dot, and then close the parentheses, and then dt. So if we were to integrate term by term, we would get this, okay? So this is the antiderivative 1 over 1 plus t squared is tan inverse of t evaluated from 0 to x, and that would be equivalent to, okay, and then this one would be, this becomes t minus t cubed over 3 plus t to the 5th over 5 minus t to the 7th over 7 plus t to the 9th over 9 minus t to the 11th over 11 plus dot 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 plus negative 1 to the n, and then this becomes, okay, this would be t to the 2n plus 1 power over 2n plus 1, and then we'd evaluate that from 0 to x. Okay, so this over here on the left-hand side becomes tan inverse of x minus tan inverse of 0. And then this, what would happen is, because we're going to kind of look ahead, okay, we would put x everywhere we see t, okay? And then we would subtract and we'd put 0 in all of these. Everywhere we see t, we replace it with 0. Well, if we replace all the t's with 0, every single term is going to be 0. So we really don't need to write that out, okay? So this is going to become x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus x to the 9th over 9, and then minus x to the 11th over 11, and notice the power and the denominators match. Okay, then plus dot dot dot, and then plus, and this would be negative 1 to the n, x to the 2n plus 1 over 2n plus 1 plus dot dot dot. Now back over here on the left hand side, tan inverse of x minus tan inverse of 0. Tan inverse of 0, okay, remember this is the ratio, and the ratio is 0 only when the angle is 0 for tan inverse, so this is just 0. So really, in essence, this is just tan inverse of x is equal to x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus dot 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 plus negative 1 to the n, x to the 2n plus 1 power over 2n plus 1 plus dot dot dot, and that's equivalent to sigma n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 over 2n plus 1. And this is the infinite series that can represent tan inverse of x. Now, right now, it's on the same interval as the original function, or not function, but the series converged to. So the original series was the one above. It converged between, on the open interval, negative 1 to 1. This one also will converge on the open interval negative 1 to 1. But it actually has more convergence than that. It's actually, the interval of convergence is actually bracket negative 1 to 1. Now, we're going to talk about this in future lessons when we start to talk about where it converges at endpoints. And that's if you look at your list of assignments, this is going to happen towards the end of this, okay? We're going to talk about endpoint convergence. And for this one, it turns out that the endpoints also converge, okay? I'm not going to do the rest, and the next page after this I'm not going to do because that really isn't going to be that important. We'll be covering that over the next few days, okay? So let me know if you have any questions, okay? And this is just the same